This 8-mark question consists of 3 parts. We're given f of x, which is x minus 3 times 3x squared plus x plus a minus 35, and we're asked to state the remainder when f of x is divided by x minus 3. Now, there is an easy way of doing this. You can just state the number, which is minus 35. However, I'll write it down in a bit more detail so you can see where this answer is coming from. The remainder, when it's divided by x minus 3, is going to be the same as f of 3. And f of 3, well, we're going to substitute all of the x's for 3. But you'll notice that this bracket is 3 minus 3. So I don't even care what's in the second bracket. I know that 3 minus 3 is 0, and 0 times anything is 0. So these two brackets are going to disappear. So straight away, the remainder will be minus 35. But if you're ever unsure, you can put in the 3 everywhere there's an x, and you can work it out. It'll just take you a bit longer. For part B, we are given that 3x minus 2 is a factor, and we are asked to show that a is equal to minus 17. So if 3x minus 2 is a factor, that means that f of some value is equal to 0. And that value will be, well, we take the 2, the opposite of the minus 2, and we divide it by the coefficient of the x. So this means that f of 2/3 is equal to 0. And what we need to do with this, we essentially need to substitute in x is 2/3 everywhere in the equation f of x, set it equal to 0, and then solve, and that should give us the value of a. So I'm substituting x in here squared plus x plus a minus 35, and that all together should be equal to 0 because it's a factor. 2/3 minus 3 is the same as 2/3 minus 9/3, which is minus 7/3. Now 2/3 squared is 4/9, which we times by 3, we get 4/3. And then the rest I'm going to keep the same. I'm going to move the 35 over to the other side. 4/3 as 2/3 is 6/3. 6/3 is also known as 2. So we get 2 plus a in the bracket. I'm going to divide both sides by 7 because I see that there's a factor of 7 on both sides. And I'm going to move it here. So we've got a bit more room. Next, I'm going to multiply both sides by 3. I'm going to times both sides by -1, or divide. And then I'm going to subtract 2. And we get a is minus 17, which is exactly what we wanted. And finally, part C, the 5-marker, the long one, we're going to use algebra to find the full factorization of f of x. So before we can even factorize it, we're going to need to expand it. What I'm going to do is I'm going to expand x times by every term in the right-hand side bracket, and then I'm going to times -3 by every term in that bracket. And then don't forget the minus 35 on the end. Next, I'm going to simplify. There's only one cube term, but there are two x squared terms which simplify. There are two x terms which simplify to minus 20x. And then these numbers will simplify to plus 16. Now it's fully expanded. Now we can try and factorize it properly. I'll show you two methods. The first one is polynomial division. Maybe a bit more standard, but it's not the quickest method. In order to find the polynomial division, we take this huge polynomial, we pop it underneath the bus stop, and we divide it by a factor. Do we know a factor? Yes, it's from part B. We know 3x minus 2 is a factor. So therefore, we divide it by 3x minus 2 and see what's left over. How many times does 3x go into 3x cubed? The answer is x squared. Basically asking, what do you times by 3x to get to 3x cubed? Then we take the x squared and we times it by 3x minus 2. We then subtract these two. The first two should cancel out if you've done it properly. And then the next two will get us minus 6x squared, and we can bring down the minus 20x to repeat the process again. What do you times by 3x to get to minus 6x squared? The answer is minus 2x. Now times the minus 2x by the whole 3x minus 2, and we get minus 6x squared plus 4x. We then subtract again. These two disappear, as expected, and we get minus 24x. Bringing down the 16 like this. How many times does 3x go into minus 24x? The answer is minus 8. Now we take the minus 8 and we multiply it by 3x minus 2. We get minus 24x plus 16. If we subtract these two, we get zeros everywhere. That means it goes in exactly, which is good, because that means we can then factorize it. So this means that we can factorize it as 3x minus 2, which we knew was the factor, multiplied by the expression on top there, the quadratic on top. To fully factorize it, or to finish off fully factorizing it, we simply put this second bracket, this quadratic, into good old-fashioned double brackets with minus 4 and a plus 2. That would be our final answer, our full factorization. For another method, which is a bit quicker, it's kind of reverse engineering the factorization. So this is the full expanded version, just like we did before. And in a similar way, we know 3x minus 2 must be a factor. So how are we going to get 3x cubed then? What can you times by 3x to get to 3x cubed? It has to be x squared. Now imagine expanding it. If you were to expand this bracket, you'd get minus 2x squared. But when we fully expanded it, it should be minus 8x squared. So there's another minus 6x squared that is missing, and that's going to come from 3x times something. 3x times minus 2x is 6x squared. So now we've got minus 2x squared minus 6x squared. That gives us our minus 8x squared. What about the minus 20x? Well, this gives us 4x. So we need to somehow subtract another 24x to get there. And we're going to do minus 8 here, because now we get 4x from these two terms, minus 24x from these two terms. That gives us the minus 20x that we want. As a final check, minus 2 times minus 8 is 16. This is exactly the same as before, which makes sense. We shouldn't get a different value from a different method. We can factorize it in the normal way, and we get our final answer. And here are two more.